Hi everyone! I am Teacher Marichu and welcome to our modular distance learning on MathBox for senior high school, general mathematics, and we are in quarter 1, week 3D. And the goal or the learning competency that you're going to learn in this module is for the learners to be able to solve problems involving rational inequalities. So let's start. Moving on to the generalizations. So I'll just leave it to you to read the generalizations. It's so easy to understand. And let us explore the example here. I'm making this quick so that I can move on to the exercises and the enrichment activity. So part of the example, we have here a box with a square base. This is x. The length and the width are equal. And we have the height h. Then the solution is here. Okay, so we have more of this discussion in the following exercises. So I'm just letting you, I'm just scrolling it down for you to grasp if in case you don't have this copy of the module. But for those who have copy of the module, you can skip the video and go directly to the exercises in this video. But for those who were not able to procure a copy of this module, you can pause the video and you can study along the way. So we have here the table of signs. Constructing the table of signs, we have this sign analysis method or the sign analysis table. So we will have a thorough discussion of this in the following exercise. Okay, for the exercises, we have 2 numbers and then we have 1 enrichment activity. But stay with me. For 1 number, we'll just have, I think, 4 pages or 3 pages for this. Let's get started. For these exercises, directions: solve the following problems and you have to show your solution in your answer sheet or your activity notebook. Number 1, a cylindrical can has a volume of 200, this is cubic centimeters, equivalent to 200 ml. Then, let x be the radius of the base of a can and h be the height of a can. What are the possible measurements of the radius of a can if its height is longer than its radius? So we have here the hint. This is volume equals pi. The pi slips up. Okay, pi r squared h. And we have to use the value of pi equals 3.14. So we round it off to 2 decimal places. For the solution, so I have here presented a drawing because I am comfortable of sketching the situation in the problem. So we have a cylindrical can with a radius of r and with a height of h. And in terms of r and h, let me denote here as the volume of the cylinder is equal to pi r squared h as given. And then, as given also, we have to let pi equals 3.14. Moving on, so we have volume, which is pi r squared h equals 200 ml. Then, it says in the problem, what are the possible values of the measurement of the radius of a can if its height is longer than its radius? So, we have to solve, or we have an inequality for this. It could be either in terms of r or h. But for simplicity's sake, we have here, since it says h must be larger, or the height is longer than the radius, or larger than the radius. So it's so easy for us in this equation to isolate or express h in terms of r. So in this case, isolating h, we get 200 over 3.14 r squared. Now, since in the condition h, the height must be larger than the radius, so we have, this is the height, meaning the volume in terms of the height, and of course the r. So it's easy for us to deal with either equations or inequality in a single variable. So this is the object of this process or step. Moving on, we have here 200 over 3.14 r squared should be greater than r. Then transpose this r to the left hand side, leaving the right hand side of this inequality to be 0. So we have 200 all over 3.14 r squared minus r. Then rewriting, this is, how did we get 63.69? We just have to simplify this. 200 divided by 3.14. So you can use your scientific calculator to calculate on this. Then we have 63.69 all over r squared minus r greater than 0. Then take the LCD. We just have to use a single rational inequality expression here. So we have LCD r squared. Then we have 63.69 minus r cubed all over r squared is, or must be, positive. When an expression or a rational expression expressed as like this, inequality is greater than 0, that means that this must be positive. Okay. So substituting the value, or getting the cube root of this. Because here, by just simply looking at this, we have a hint that, oh, the numerator is a difference of 2 perfect cube. So let's find the cube root of 63.64. Take note, 63.69. 63.69 is almost closer to 64. So we expect that the cube root is almost closer also to 4. What did I say earlier? 64 is a perfect cube. The cube root is 4. 4 cube equals 64. So we expect that the cube root of this is somewhat closer but not equal to 4. So in this case, using the calculator, cube root of 63.69 is 3.99. Expressed it in terms of cube minus r cube all over r squared is greater than 0. So this is our object for now, to solve this inequality, and what are the values of r that will satisfy this given inequality. Now, it is better for us to factor the numerator in order to solve or to find the critical values for r that we're going to use. Okay, recalling the special product on the difference of 2 perfect cubes. So we have here, say, a cube minus b cube, and the factors a minus b times the quantity a squared plus ab plus b squared. So we have our r equals, a equals 3.99 and b equals r. So recalling the inequality, we have 3.99, the factors are of 3.99 cube minus r cube. Factors are quantity 3.99 minus r times quantity 15.92 plus 3.99 r plus r squared all over r squared greater than 0. Since all the expressions in the numerator are in factored form, we can set each factor equal to 0. Let's do that with 3.99 minus r equate to 0, giving us r equals 3.99. And here is the other factor. It's a bit complicated, so let's try first to get the critical value for the denominator r squared. Set this also r squared, set the r squared to 0 to get the critical value of x. So although this r equals 0, will make this expression undefined. But then there are two critical values of x that we can have in here. Set the numerator equal to 0 to get the value of r that will make the inequality or the rational inequality 0. And another one is set the denominator equal to 0. It will make the expression undefined, but it doesn't matter as long as we get the critical values for r. That is our object for this process here. Now, moving on. So we have already two values for r. Critical values are 3.99 and r equals 0. Solving for the other factor, solving for the roots of this, we have to check if the real 0 exists using discriminant. In this case, we identify the coefficients of r squared, a equals 1, coefficient of b or r is 3.99, and the constant is 15.92. Solving for b squared minus 4ac, or the discriminant, we found out that we have a negative discriminant. Hence, no real root exists because of the negative discriminant. In other words, the roots are two complex roots or imaginary roots, and this is beyond the scope of our module. So we will only consider the critical values for r to be 0 or 3.99. Okay, let's construct now the sign analysis table. I forgot to label this. This is actually the sign analysis table, or SAT. But anyhow, recalling our r critical values to be 0 and 3.99. Okay, let's plug in here. This is r equals 3.99 and r equals 0 here. And let's imagine that this is a real number line for r. And on the interval row, this part of r, meaning to the left side of 0, of course, the interval is from negative infinity to 0. Or meaning r here is less than 0. I keep on talking r, but r is the radius. Okay, on this interval, this is the interval values for the radius between 0 and 3.99. So we can write this as an open interval 0, comma, up to 3.99. Or we can rewrite as 0 less than r less than 3.99. Either way. Okay. In this case, of course, to the left side of 3.99 is the interval r, open interval r, open interval 3.99 going to positive infinity. That means that r is greater here than 3.99. How did we choose negative 1, 1, and 4? Well, choose negative 1 within this interval. The negative 1 falls in this interval, so we have negative 1. Then 0 to 3.99, 1 is there. The most convenient value is 1. Then 3.99 to positive infinity, there are a lot of numbers, but the most convenient value for r is 4. Okay, then here are the expressions in the numerator of our rational inequality. So the first one is 3.99 minus r. Then the second one is the other factor, 15.92 plus 3.99r plus r squared. And the third is the denominator r squared. Now the purpose is just to plug in the signs. Now let's do this like this one. Let's start with the test point on this column going down. How did we get these 4 positives here? So if r equals negative 1, substitute it to 3.99 minus r and get the sign. So 3.99 minus 1 is 2.99 and it's positive. Moving on, substitute here r equals negative 1. Here is 3.99 times negative 1. This becomes negative. So we have 15.92 minus 3.99. That is also still positive, plus negative 1, square that, it's positive. So it's a positive sign. And in this case here, -1 for R, raise it to 2, -1 quantity squared, it's still positive. And how did we get this green circle plus sign? Well, we have here, what is the sign of this factor? It's positive, times this factor, which is positive also, that becomes positive, divided by this factor, which is positive. So the resulting sign of the rational inequality is positive. Now, if R equals 1, test point, so we have here positive also, substitute 1 here, positive, and also substitute 1 squared, it's obviously positive. Then operate on this with the sign, positive, positive over positive, the result is positive. Moving on, if the test point equals 4, substitute it here, 3.99 minus 4, that's negative, because 4 or -4 is larger than 3.99 here. Okay, then substitute this to the second factor in the numerator or in this expression, so we get a positive value. Then 4, square that positive. Then what is the sign of the first factor in the numerator? It's negative, times positive, that becomes negative, divided by a positive, it becomes negative. Now, to recall our inequality, the required inequality is this one. How did we say it's positive? It says here that this whole expression must be greater than 0. So an expression greater than 0, that means that it's positive. So in the final or in the last row of our sign analysis table, the required sign must be positive. So there are two intervals at which our radius will be positive, or I mean our rational inequality will be positive. So these are at the given are from -infinity to 0 and from 0 to 3.99 intervals. Between this, take note, there's a note here with an arrow. The interval, this particular interval, is an extraneous solution. Why? Of course, we're dealing with negatives here for R, the radius. And take note, we are dealing with positive or quantities, tangible quantities, say radius, height, and in this particular problem. So meaning, it must be positive. Negative value is nonsense or irrelevant. Okay. So R is always positive. So our R or the radius must be within the interval 0 to 3.99, or we have this notation. Therefore, the radius of a cylindrical can must be in the interval 0 to 3.99, or this symbol, for the height of the can to be greater than its radius. And we're done with exercise number 1. Let's continue for number 2 problem. Let me read the problem. Mr. Cruz wants to publish his own math textbooks. A company will do it for him if he pays 7,500 pesos plus another 750 per book. Mr. Cruz decides that it will be worth it if he can produce books for less than a price of 1,000 pesos each. How many books should he produce to make it worth it to him? Okay, hint, multiply the number of books to its cost and add it to 7,500. Now, in this case, we have in economics, we have an economic term here. This is the fixed cost, the 7,500. Even if, say for example, Mr. Cruz will agree or will close the contract with the publishing house, then even if Mr. Cruz can only produce one book, then he has to pay 7,500. Of course, Mr. Cruz has also to decide that it will be worth it in producing the books. So, of course, this is what we call fixed cost. And the 750 per book is what we call the variable costs. So, for the solution, number 2, we have here the term revenue. So we let R of X be the revenue of publishing the books, R of X. It says there that Mr. Cruz, it's worth it if he can he can sell, or the company can sell the book for him in less than 1,000 pesos. So the boundary or the limit or the ceiling price is actually 1,000 pesos. So let it be that the revenue, for example, let's say the book costs 1,000 each, because that's the ceiling for Mr. Cruz to decide if he go for the contract or not. R of x equals 1,000 times x. Oh, what is x? Oh, I forgot to define here. Okay. Let's define here x equals the number of books to be produced. X equals the number of books to be produced. So that we have R of x is equal to 1,000 times x. That's the revenue. Okay. For the cost, let C of x be the cost of publication. So it's given earlier there that the variable cost, meaning the number of copies of books produced times the price of the company, is 750. So we have the variable cost to be 750x plus the fixed costs, 7,500. So the cost function in this particular problem is C of x equals 750x plus 7,500. Now let us also have this P of x function to be the profit of publishing the books. We know that profit is equal to revenue minus the costs. And it should be that P of x is greater than 0, of course. For Mr. Cruz to decide that, oh, it's worth it publishing my book, so I can go for the contract of the company. Okay? So we have to determine what or how many books he has to publish in order to lower the price from 1,000 pesos to lower than 1,000. Okay, so recalling, we have R of x equals 1,000x minus the C of x minus 750x minus 7,500, and P of x is here. And in this case, it has to be that P of x is greater than 0 here. So how to recover P of x? So I had written here P of x greater than 0, then this is equal to 1,000x minus the quantity, the C of x, 750x plus 7,500 greater than 0. I'll just rewrite everything in this to make it clear. Then proceeding here, we have to substitute, to take away the grouping. Okay, so 1,000x minus 750x minus 7,500 should be greater than 0. Okay. Then, combining like terms, 250x then minus 7,500, but the 7,500 can be transposed on the other side to get the value of x. So moving on, this one cancels out. 250 divided by 250 is 1. So x. And cancel the 0 and the 0 here. Then 75 and 25, that's 3, and 0 we have x is greater than 30. Now checking, just to convince ourselves that Mr. Cruz has to produce more than these 30 books. Checking out, x is less than 30. Say x is greater than 30. I'm just getting excited to tell you the conclusion. Anyway, say x equals 31. What is P of 31? Well, recalling the P function or the profit function above, the R of x minus the C of x. Okay, so we have it here. Well, 1,000 times x, 31, it's 31,000 minus 750 times 31 plus 7,500. So we have P of 31, or this is meaning if Mr. Cruz decides to produce 31 books with the company, he has a profit of 250. And Mr. Cruz, by saying if it's worth it for him, meaning it's okay for him, maybe I'm just empathizing with Mr. Cruz. It's okay for him even if he has no profit. So this 250 can be divided to 31. 250 divided by 31, that's, so it's 8 pesos. So 1,000, which is the ceiling price or the maximum price of the book, minus 8 pesos, it is 992. So it is less than 1,000, which is what is Mr. Cruz wanted, that the price of the book must be less than 1,000. So therefore, Mr. Cruz must produce more than 30 textbooks in order for him to say that it's worth it. Okay, so this concludes our discussion for this module, and this is Teacher Marichu saying stay happy and healthy and God bless us.